In this video, I'm going to be talking about how to solve systems of equations using the method called substitution. In the previous video, we did by graphing. Now we're going to do substitution. So when solving by substitution, solve at least one equation for one variable. So I'm solving one equation for one variable. Typically look and see is the coefficient 1. Substitute the resulting equation from step 1 into the other equation. Don't put it into the one that you just solved for y for. You're going to get it wrong then. You're going to get like a all real numbers type of answer. Okay, now we solve the equation. You're going to solve for a variable. Then you plug that variable into one of your two equations, and your answer, write the solution as an ordered pair. That's going to be key also. Okay, so we have equation 1, y equals negative 4x plus 12. And then we have the other equation, 2x plus y equals 2. Now, the substitution screams out at me here. Why does it scream out at me? It screams out at me because the y is already solved for. So, in the red equation, I have 2x plus y equals 2. I'm going to take this equation and put it in there. So, and then I'm going to solve. So I have 2x minus 4x plus 12 is equal to 2. So I have x equal to 5. So x is equal to 5. We need the answer as an ordered pair. Now plug back into one of the two equations. I think the first one is easiest. And your answer is 5, negative 18. Okay, use substitution to solve that system of equations. So I just want you to examine. Look at this first equation. Notice how on x, the coefficient on that is 1. So that makes it really easy to do substitution. If I were to solve that equation for x, so I get x equals. So now what I'm going to do is I'm going to substitute into the other equation. 3x, I'll worry about that in a minute, plus 5y equals 24. So then we have 2y minus 3. I plug that in. Now I solve. I distribute the 3 inside to both terms. I add 9 to both sides. I divide by 11. So my y coordinate in this case now is 3. I substitute back into this equation, or even this one I manipulated. I'm going to use the one I manipulated because then I'm going to be able to solve for y right away. Or for x, I apologize. So x equals 6 minus 3. And there's your answer. Okay, use substitution to solve that system of equations. Again, what I see here is I see that you have that top equation has coefficients on the x's and the y's. But the bottom equation has the coefficients are both 1. So I'm going to solve this bottom equation for y. I'm going to subtract x over. Then I'm going to substitute into the other equation. And now I'm going to simplify. So if I distribute this 2 through, I get negative 2x minus 4 equals 8. 2x minus 2x, oh, that ends up being 0, so I have negative 4 equals 8. Is negative 4 ever going to equal 8? This never happens, so that means you have no solution. So now this other one. Okay, now this one's a little challenging because you see, if you look there, all of my coefficients are going to be, they're all not 1. So, I mean, you could pick any one you want. I'm personally going to pick the top one just because the numbers are a little bit smaller. So, solving this for a variable. You could solve for either x or y. What I notice right away is this 2x is negative. So if I add that over to the other side, I get that. And then I divide by 3. Now, using substitution, you want to try to avoid this happening. Sometimes it's just going to happen. Okay, but you want to try to avoid that happening. If you have it, it's okay, but you really want to avoid it because many students don't like working with fractions. We're going to substitute this into the other equation. Okay. Now, distribute the negative 6 through. I'm going to do a little work up here. Negative 6 times 2/3. 1, 2, that's a negative 4y minus 6 plus 4y equals a negative 6. The 4y's cancel. I get negative 6 equals negative 6. This always happens. This is always true. So that's why our solution is all real numbers. If you think back to the 6-1 video, what this means is that this is the same line. So this is consistent and dependent. Going back to this one would be inconsistent. So just using those vocab words from previous sections in this section also, understanding we can use that same vocab in this section. Thank you for watching my video.